Here's the quick recap for free fall. Free fall is when objects are falling, going downward, and they all fall with the same acceleration. That acceleration is called g, and it's always 10 meters per second squared downward. That means that no matter what object it is, no matter how big it is, if it's near the Earth's surface, then it's going to fall toward the Earth with an acceleration of 10 meters per second squared. They might not give that to you in a problem. You have to know that the acceleration is 10 meters per second squared for anything that's falling. Basically, that means the velocity keeps increasing 10 meters per second every second. Now we can talk about Newton's laws. The first law is that objects at rest will stay at rest unless acted upon by an unbalanced force, and objects in motion will stay in motion with a constant velocity unless acted upon by an unbalanced force. In other words, if there's no net force, if the net force is zero, then the velocity is not changing. That's Newton's first law. Newton's second law is about what if your net force is not zero. The net force is going to equal mass times acceleration. What is it that we mean by net force, by the way? Net force is the sum of all the forces, meaning you add them up, except when things are going different directions, like if that one's going to the right and this one's going to the left, and let's say this is 10 newtons to the right and 5 newtons to the left, then when we add these up, the net force is not 15, it's actually positive 10 minus 5 newtons. So it's 10 minus 5, in this case that would be 5 newtons. If the mass was 2 kilograms here, then we can plug in what we know here to our equation. The net force is 5 newtons. It's equal to the mass, 2, times the acceleration, and we can solve for acceleration. We could divide by 2, divide by 2. We end up with the acceleration as 2.5 meters per second squared. And we always want to include a direction with acceleration. When you see arrows that are bigger in one direction, including the number, you can see the number is bigger going in this direction. That means the acceleration is going to be in that direction. So since there's more force going to the right, the acceleration goes to the right as well. The acceleration and the force go in the same direction. Let me give one more problem. What if we have an object like this, and it's got 2 newtons of maybe drag force going up, and we've got some amount of force going down, and we're told that the net force is 8 newtons, then how do we figure out what F is? Well, the net force is going to be these forces added together, except up we might call positive, and down would be negative. So if the net force is 8 newtons, really this should include a direction. Let's say 8 newtons down. Then we can say that's really the same thing as negative 8 newtons. So we can write negative 8 newtons, the net force, is equal to the forces going up, that's a positive 2 newtons, plus the force going down. We can subtract 2 from both sides, 2 newtons, and we end up with F is negative 10 newtons, or in other words, it's 10 newtons downward. So another way to think about that, if you're not familiar with writing an equation like this, you can think, you know the total is going to be 8 newtons down. That means that whatever this is has to be 8 newtons more than that, but downward. 8 newtons more than 2 would give you 10 newtons. There are a couple of forces that you need to be aware of. One of them would be the gravitational force, F sub g, and that is the mass of the object times g. We already saw that g was 10 meters per second squared. So if you know an object's mass, you multiply it by 10, that gives you the force due to gravity, otherwise known as the weight. There's also the normal force, F sub n, that's when you've got something like a table, and maybe there's a box on the table, and the table is going to push up on the box. So basically, when two things are in contact, the normal force is going to push out of the surface. We also have tension force. The tension force is when you have some sort of a rope or a string or cable or anything, something that's maybe holding a box. Let's see, like maybe there's something from the ceiling holding a box. There would be tension in the string, so this tension would be pulling up in this case. Besides that, we also have friction forces, which always oppose things as they slide or as they're trying to slide. So if we've got a box and somebody's pushing on it, if they're trying to push it to the right, then the friction is going to be to the left. That's if it's moving to the right or not. If it's before it's moving, regardless, if they're trying to make it go to the right, the friction is going to oppose and resist and go to the left. On to Newton's third law, if I could. Newton's third law. Every force, every action force has an equal and opposite reaction force. What that means is whatever force you have, if you push on something maybe, if this guy pushes on the wall with some amount of force to the right, let's say it's 10 newtons, then there's going to be an equal amount of force, so again 10 newtons, but it's going to push to the left. That's the opposite part. So the F as a reaction force is going to be 10 newtons to the left. This one's to the left, the other one was to the right. So every force has a force that goes in the opposite direction, but has the same amount of force, same magnitude of force, but in the opposite direction. Even a bug hitting a windshield, the force of the bug hitting the windshield is going to be the same as the force of the windshield hitting the bug.